So if you look at it from a quadratic standpoint, okay, what is the domain of all quadratic functions? It's all real numbers, right? And an absolute value function. So that means that whatever x is, it is going to satisfy, it needs to satisfy both of those criterions. So we know that in that case, the domain of this is going to be all real numbers. Because both quadratics and absolute values, the domain is all real numbers. Okay? Now, basically, what is this telling you? It is telling you that whatever x is, it's going to take it and it's going to put it above y equals 0, okay? Because the final say is that absolute value function. It says, hey, if you go past me, everything that the output was a negative now becomes a positive. And so if you think about it in that regard, you see this parabola is going to look like this. And if it's above y equals 0, then it's going to be fine. It's still going to be y is greater than or equal to 0. But if the parabola is below, then what happens to this little bit right here? This little bit right here. That is below y equals 0. What's going to happen, it is going to actually reflect over the x-axis. And it's going to now look like that. Okay, and that's what a absolute value, absolute quadratic function looks like. Okay, so let's go ahead and graph this. Okay, oh, let's first figure out the range. The range is going to be y, such that y has to be greater than or equal to 0. As long as you don't see a reflection out there, you don't see any kind of reflections going on. Okay. Here is that. There is this. And then let's just graph the quadratic. Okay. First of all, we need to find the vertex. It's going to be negative b over 2a. So that's going to be negative 1 over 2 times 2, which means it's negative 1 over 4. And then let's go ahead and figure out my y value of that. So y equals, and I'm just going to do it like a quadratic. I'm going to right now disregard the absolute value sign. So 2 and negative 1/4 squared plus negative 1/4 minus 3. Y equals 2 and 1 over 16 minus 1 over 4 minus 3. So that is y equals 1 over 8 minus 1 over 4 minus 3. So that's going to be, let's go ahead and put it into the calculator. 1/8 minus 1 divided by 4 minus 3. And then I'm going to change that into a fraction. So negative 25 over 8. Okay. So negative 25. So if I start making some values on this table, you don't want to make it there. We'll make it here. X and Y. So we had negative 1/4, and what's that number? Negative 25/8. Negative 25/8. Negative 25. Negative. So it's going to be, let's go ahead and put some markers on this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6. Yeah. And then negative 25/8 is, what is that? 3 point somewhere. Very close to negative 3. Somewhere here. Now notice that that vertex is below our range. And that's because we didn't put the absolute value sign on it. But if I put the absolute value sign on it, this turns into a 25/8. Okay, so what I need to do first is figure out, okay, all of the actual graph that is going to be above the x-axis. In order to do that, I have to find my zeros or roots. How do I find roots of a quadratic? You factor. Okay, so we have 0 and then 2x squared plus x minus 3. We have 2x, x, and that is going to be a plus and a minus. Nope. It's going to be a minus and a plus and a 3 and a 1. Yep, that's right. And so x equals negative 3/2 and x equals 1. So x equals 1 and x equals negative 1.5 right here. Well, that doesn't look, well, negative 1.5. This is because 0.2, I didn't graph this vertex very well. And it would probably be more like, no, and I didn't even really need those anyways. Probably be more like negative 1, 2, 3. It'd probably be more like that. Okay, and then we can figure out that this parabola is gonna go up like this. Right? We know that much. But everything else that happens in between here is going to be below. It's going to happen below the y. But once again, we have the other whammy, which makes this an absolute value function. So what you can do is just take this vertex and graph it with this output. So now it's negative 1/4 and 1, 2, 3 somewhere right here. Okay, it's going to be negative 0.25 and it was like it's going to be a positive 3.125. So this is going to be a positive 3.125. So somewhere around there. And then you could just connect these. Looks kind of interesting, right? But basically, all it's doing is taking the part of this parabola, okay, that is below y equals 0 and just reflecting it up. Just reflecting it up. And that's what's happening. All the y values are now the outputs. Because of that, the powerfulness of the absolute value, it just reflects it up. It just makes them positive, which is kind of like a reflection. Okay? Good job. Next one. Oh. Okay. So for this one, we have pretty much the same deal. We have this quadratic inside. And once again, quadratic, absolute value. The domain is going to be x such that x is an element of all real numbers. Now, the y, okay, we have to look for it. I mean, the range of this quadratic is going to be y is, it looks like it reflects. So it's going to be less than or equal to whatever that vertex, the b value of the vertex is, right? The y value of the vertex. Okay. The y value of vertex. But then the powerful absolute value does its thing on that. And so once again, it's going to reflect. Okay. And then you realize that this function goes up to. So think about it. If I have a quadratic, and it doesn't matter how low or below the x-axis it goes, how below the x-axis it goes, if I put an absolute value on it, all that's going to matter are these 2 points right here. That's going to be my lowest point. Everything else is going to move up like this, or it's going to become positives. All these negatives are now going to become positives. Okay? It doesn't matter what is below here. And this is going to be y is greater than or equal to 0. The range is going to be y is greater than or equal to 0. Okay? Now, think about that. And think about this number right here. All that's doing is moving it up 2. Every single one of these points are just going to be moved up 2. So this point, which determined before the lowest number on the range, is now going to be moved up 2. So now it has to be greater than or equal to 2. Okay? So if I moved it up 4, this would be greater than or equal to 4. If I moved it down 2, it'd be greater than or equal to -2. Okay? So the range of this is going to be y such that y has to be greater than or equal to 2. Wow! What is that parentheses in the end? Now let's try to graph it. Remember I said what's really important is the vertex and the x-intercepts. Okay, those are the two important things of that quadratic. So we have y equals -5x squared minus 13x plus 6. Okay, we're finding 0, so set y equal to 0. -5x squared minus 13x plus 6. I'm going to take out a negative, and 5x squared plus 13x minus 6, and then factor 5x, x, and plus, do I want plus there? Nope. I want minus there. Nope. I want plus there. I want minus there. And that's going to be what? 3 and 2, 15, and minus 2. I think that works. Okay. So that is going to be equal to 0. And so x equals 2/5. Okay, and x equals -3. Okay, so let's start graphing these points. I don't want that. I don't want that either. Ooh, -3 right here. That, and let's see, 1, 2, 3, and 1, 2. So it's going to be -3 and 2/5. We're right there. But remember what happened to them right here. It went up 2, right? So now, where it was before 2/5 and 0, and -3 and 0, now because they moved up 2, it's going to be 2/5 and 2, and -3 and 2. Okay? And so 1, 2. Like that. Okay, so now we have to find the vertex. Okay, so I'm going to take that function and I'm going to find x equals -b over 2a. So that is going to be positive 13 over 2 times -5, which gives me 13 over -10. Ew! Sorry. $13 divided by $13 divided by -10. So that's going to be that, and I'm going to store this as x. And then I'm going to put it into my function. So that's a -5x squared minus 13x plus 6. So that's 14.45. So the y value is 14.45. Okay. Didn't it reflect? Interesting. Moved up 2 too. Okay. -1.3 and 14.15. I have to count 14. Oh man. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So -1.3, -1.3 right here, and 14.45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 2, 4, 4, 5, somewhere right here. I'm gonna connect that just like this. And then what happens? This function will continue to go down, right? But we've set the range. It's going to be a greater than y equals 2 or equal to. So all of those numbers below that is going to actually reflect. So if I just pick one point, okay, maybe right here, x equals 1. And if I put it into the function, store it as x, and then, yeah, this calculator won't let you actually go back and copy. I think it can. Let me go ahead and try. So let's go into entry. No, it's going to let me. Well, anyways, okay. You should have a function if you have the fancier calculator that you can kind of go up and copy that exact same thing, that line, and you can just press enter. So that's negative 12, right? When I put x equals 1 into it, it gives me a y equals negative 12. But then what does absolute value function do to that negative 12? It makes it positive 12. And then you have to add 2. You have to add 2. So that means that that's 14 right here. So that's going to be that right there. And then if I put in a number like 1, 2, 3, 4, x equals negative 4, negative 4, store as x. Let's go ahead and put that back in, negative 5 minus 13 x plus 6, negative 22, x equals negative 4. That's going to give me an output of y equals negative 22, but then it's going to take it and make an absolute value, so it's going to be 22 plus 2 equals 24. Yeah, no, not going to do it. Just going to draw one of those. Okay? Whew. Fun times. Good job. Okay. Now, enough graphing. Now we're gonna solve equations. Yay! Algebra! That is my oasis. I always think algebra is like my little oasis in my desert. I am not a fan of grapher. I became a fan to teach. But for me, if I had to choose, I love just solving pure algebra, or later on, trig identities. That's my thing. Okay, so let's go ahead and solve. Now we need to isolate the absolute value. Minus 10, minus 10. Value 3x plus 2 equals negative 3. Divide both sides by a negative. Absolute value of 3x plus 2 equals 3. Let's break this up. So that means that it is 3x plus 2 equals 3, or 3x plus 2 equals negative 3. So subtract 2, so we get equals 1, x equals 1 over 3. And then minus 2, 3x equals negative 5. 5 over 3rd. And if I check my answer, I always like to check in here, divide by 3, stores x, 10 minus absolute value, 1, 3x plus 2 equals 7. And then I can just go ahead and put that in there and then multiply that by -5 divided by 3, close that parentheses, plus 2, and it's also 7. They both work out. Okay, bye. Let's go ahead and add 3 to both sides. We have 8 times absolute value of x plus 7 equals 8. Divide both sides by 8, so we have absolute value of x plus 7 equals 1. Split that up, x plus 7 equals 1, or x plus 7 equals -1. So x equals -6, or x equals -8. Let's go ahead and check work. So I have 8 times absolute value of, let's put in a -6 plus 7 minus 3. That should give me a 5. Take that and put in, let me do it with my mouse so you can see my keys whenever I put it in there. Okay, and then I'm going to put in a -8, and it gives me a 5. Okay, so they both work out. Okay, next problem. A, B, C, C. Okay, let's go ahead. There's 2 ways to solve this. You could square both sides if you want to remove that x minus 2 from the absolute value, or you can break this absolute value up into 2. So we have an x minus 2 equals, and you can negate either side, x plus 1 or x minus 2 equals positive 2x plus 1. And what I mean by that is you could also say that it's negative x minus 2, and then just keep the right hand side as is, or positive x minus 2, 2x plus 1. So keeping the right hand side or the left hand side is up to you. It doesn't matter. You're going to get the same answer. So x minus 2 equals negative 2x minus 2. And then we have an x equals 0. Okay. Is that 0? Is that right? Positive. Oh, why? What am I doing? I'm sorry. Just having a whole bunch of people texting me right now. Because, you know, I bring the fun. No, I'm just kidding. That's not why. Okay. Plus, it's still not giving me what. Oh my goodness. What did I do right here? Yeah. And then equals plus 2, 1. So x equals 1/3. Okay, and then we have x minus 2 equals 2x plus 1. What was the answer? And I'll do. So that's x equals -3. Okay, I got these two answers. -3, x minus 2, x minus 2 equals. Now, one of the important things that I mentioned in class is that this is actually a systems of equations. So we have a y equals absolute value of x minus 2 and y equals 2x plus 1. Okay, and so you can either graph that and figure it out, but in most cases, when it involves an absolute value equaling, when you get down to here, when an absolute value equals a constant, okay, when you solve, both of these answers are actually going to work, okay, because you're really not manipulating much. You're just setting that absolute value or the number it equals to, and it's just it's purely something that is a part of the equation. Okay, but when you're solving something like this, what you are doing is you're assuming that it's going to have two intersections. So you're assuming that it's going to have two intersections. But it's not always, okay? Because when you have a horizontal line, and an absolute value function, okay, unless that horizontal line is like y equals 0 and that absolute value function did not move at all, if it's y equals 0, okay, and it just touches it on that vertex and that absolute value function did not move up or down at all. But in most cases with a constant, you're going to have two. But when you're talking about a linear function like that, there might be a possibility that you're going to have either 1 or 2. I don't see any case where you're going to have, oh, I mean, you might have 0. No, you can't, because even if the absolute value falls down here, at some point, these two linear functions are going to meet at least one point. So what you've done for C is kind of manipulated this problem to give you the most answers possible. So I have to check, okay? I have to check if the left-hand side equals the right-hand side. And you can either check by putting it back into the equation, or you can check by graphing. I'm going to graph this really quick. The math, absolute value, x minus 2, 2x plus 1. And if you can see, okay, this slope right here, that slope right here, okay, is, well, this slope right here of the absolute value is way less steep than this slope of that linear function. So this one is going to constantly go out this way, but this one's going to get steeper and steeper and steeper. So it's never going to touch. It actually just has one. So once again, the easiest way to do it, the check is by algebraically, but you can check graphically. Okay, so let's put this in. We have 1/3 minus 2 equals 2 times 1/3 plus 1. Does it work? We have negative, what is that? 1 2/3. Negative 1 2/3. And this is going to give you 2/3 plus 1, which is 1 2/3. It checks out. Negative 3 minus 2. 2 times negative 3 plus 1. That's going to be negative 5. And negative 6 plus 1. And so we have 5 equals negative 5. It doesn't check out. So this one is a extraneous solution. And x equals 1/3. Oh, that looks like watermelon colors or Christmas colors, kind of. Yay! Okay, good job. Next one. Yes. Let's go ahead and split it up. 4x plus 3 equals negative 3 minus x, or 4x plus 3 equals 3 minus x. We have 4x plus 3 equals negative 3 plus x. 3x equals negative 6. So x equals negative 2. I have a plus. It's going to be a 0. I love zeros. X equals 0. So there you go. Let's go ahead and check. For this one, absolute value, 4 times negative 2 plus 3. Does it equal 3 minus x? Oh, 3 plus a 2. So we have a negative 8 plus 3 equals 5. And that's negative 5, and then absolute value of negative 5 is 5. This checks out. We have 4 times 0 plus 3 equals 3 minus 0. So we have 3 equals 3. 3 equals 3. They both check out. Or, good job, guys. Let's keep on going. Keep on going. Okay. And for this one, absolute value. Should I square it? Should I? Yeah. I'm gonna go ahead and square this, because that's the other way to solve it. Uh, 16x squared plus 9 times 4 times 9 times 4 times 2, 72x plus 81, 4x squared minus 4x plus 1, and then we have minus 4x squared plus 4x minus 1 equals 0. So that is 12x squared plus 76x plus 80 equals 0. Why did I decide to do this? 76 divisible by 12. Nope. Is it divisible by 6? Nope. Is it divisible by 4? Nope. Yeah, it is. Okay. Okay, so these are all divisible by 4 and 4. So that would be 3x squared plus, what was that, 76? 19x plus 20 equals 0. That's going to be 10. Nope. Okay. Let's go ahead and factor. Please factor. I always beg the numbers to factor properly. Okay, let's try 4 and 5. No. 5 and 4. 15, 19. Yes, yes, yes. So that means that x equals negative 4 over 3. X equals negative 5. Okay, let's check my work to see. And you could have solved it the other way, which is you could have taken 4x plus 5 and then have it equal plus or minus 2x minus 1. Or you could have done plus or minus 4x plus 9 and have it equal 2x minus 1. You could have solved it that way, okay, and had 2 equations. This is or, okay? We're not going to have 4 equations. You could either choose to take the plus or minus side of each of the sides, but you can't do both, okay? And then, how do I want to, I don't want to just use my calculator for, store it as x, store it as x, and the math. I got so good at using my graphing calculator when I was at school, when I was in high school. I read the entire manual, and so in Cal 2 they took the calculator away from me because I knew how to solve everything. I knew how to use every single button. Okay, and then I'm going to insert, and I'm going to try to solve for negative 5. No, I'm going to delete that. Delete 2 times negative 5, and then minus 1. Ah! It's harder to do it on the keyboard. And then you're going to take the absolute value. You're going to try to look at it with the other side. 4 times negative 5 plus 9. Especially the way that my setup is in my room, that I have the mouse. I'm a right-handed person, but I'm clicking it with my left hand, so. But they both work, yay. Yay, yay. Next. Whoa. Fun. Now, you can square both sides at this moment. But if you square both sides, think about what you're doing. You can treat these like parentheses. And when you square that, when you square this entire thing, and squaring 0 is easy. Come on, I could square zeros all day long. But when you square that, look what you have. You have 2 of those in that bracket. Okay? So I don't want to do that, because I just don't. Not today. So what I'm going to do is I'm going to move this one to the other side. Just like this. Okay? Now, let's go ahead and solve it by making this side plus or minus. Plus or minus 5x plus 3 equals, oh, those are two different colors. Is it just because it's darker? Or, that was interesting. Sorry. Notice that. That looks like a different color. Interesting. Okay. Anyways. So we have 5x plus 3 equals 2x minus 1, or negative times x plus 3 equals 2x minus 1. So we have a 3x equals a negative 3, negative 4. X equals negative 4 over 3. And negative 5x minus 3 equals 2x minus 1. Plus 1, negative 2 equals positive 5. 7x. And we have x equals negative 2 over 7. Yes, yes, yes. Ooh, fractions. I had paused a little bit and then I thought I started, but I was talking and it wasn't recording. So I'm going to go ahead and check this. Negative 4 divided by 3 and store it as x. I'm going to put this whole left side into the calculator. Okay, so let's see. I'm going to go into math. I'll put absolute value 5x plus 3 minus absolute value 2x minus 1 equals 0. Yes. Now I'm going to take that, my x equals something else, and so I'm going to go ahead and delete, insert. I'm going to insert multiplied by negative 2 divided by 7. And then delete, and I'm going to insert. I don't think I need a multiplication. Multiplication, negative 2 divided by 7. I didn't insert it, minus 1. 0. They both work. Yay. And you could graph both of the absolute values and check if you wanted to. Okay, good job. Next one. I forgot one in the video. Where's my pen? There it is. Okay, let's go ahead and solve this. Okay, I'm just going to take the plus or minus of one side. It's going to be 2x minus 5 over 3 equals 3x plus 4 over 2. And then it's going to be a 2x minus 5 over 3 equals a 3x plus 4 over 2. And then I can take that negative and I can attach it to the denominator or the numerator. Doesn't really matter. So I'm going to take 2x minus 5 and then attach it to the denominator. 3x plus 4 over 2. We can cross multiply, or we can multiply this by 3, multiply this by 2. And you're gonna get is a 4x minus 10 is a 9x plus 12. So That's a minus 12 minus 4x, and 5x equals a negative 22. Divide by 5, divide by 5. So x equals negative 22 over 5. Solve the other one. Multiply this by 2, multiply this by negative 3. 2, so 4x minus 20 equals negative 9x minus 12. 13x equals positive 20, and that's an 8, so x equals 8 over 13. Huh? Is that right? Two times 5 is not. So plus 10. Sorry guys, it's just that I've made so many videos. I was solving so many problems this week. Kind of like your entire 3 weeks with me. Now I know what you guys have to go through. Okay. We can check if we want. I know it's going to work out because I just do. Or this. Okay, good job. Solve the inequality and graph it. Okay. Okay. And remember, the rules about inequalities. Okay. When we have an absolute value less than 6 or less than whatever, when I take it out, and remember distance, so it's going to be all the distances between negative 6 and 6 because it has to be less than. Okay, it's going to be all the stuff in between like that. This is negative 6 and 6. So it has to be less than 6, but it has to be greater than negative 6. And these are going to be open circles, by the way. Okay, so let's go ahead and take it out. Ba-bam. Ba-bam. And this is a compound inequality, and all we have to do is solve it. 3, negative 9. And negative 9 halves less than x is less than 3 halves. It wants me to check it graphically. Okay? So let's go ahead and check it graphically. Could I use my graphing calculator for reals though? I don't know. I assigned it. How would you use your graphing calculator? What I need to do is I need to graph y equals absolute value of 2x plus 3. And I need to graph y equals 6 and see which x's are going to be below 6. Okay? So let's go ahead and I'm going to use my 2x plus 3 delete Claire fetch graph. Which ones are going to be below? And so what I could do is I could look at where they intersect. Calculate, look at the intersection. Let's look at the first one right here. And notice what I do, I kind of put it close to it. Okay, put it close, enter. So negative 4.5 and 6. There it is. But it has to be less than that. And so it's going to be all of this area right here underneath it. Okay? And then I could find my other intersection. Second, calculate intersection right here. Enter. There's 1.5. And so it's going to be all the areas that are below 6. Y equals 6. So that is going to be, where's my other detachable LCD? I could make this big if I wanted to. So it's going to be this area right here. Right here, that's below. So that was negative 9/2 and 3/2. All of this area right here. Okay? Good job. I'm just using my graphing calculator to check. Okay, next one. Now, this one is going to be greater than or equal to. So greater than or equal to means that whatever's inside of the absolute value function, it's going to be either less than negative 5 or greater than 5. Okay, because we're talking about distances over here, right? Distances. That's what absolute values mean. It's the distance away. Okay, the distance away for that number has to be greater than or equal to 5. Negative numbers, their distance is the same. It's the same magnitude as a positive number, a positive counterpart. So this is going to be an OR statement. 2x minus 3 greater than 5, or 2x minus 3 is less than or equal to negative 5. So add 3 to x greater than or equal to add 8, and x is greater than or equal to 4. 2x less than or equal to plus 3, and that's a negative 2, so x has to be less than or equal to negative 1. Okay? Now, let's go ahead and check. Absolute value to x minus 3 and 5. Graph that. It has to be greater than, I'm just going to use the trace function. Like negative 1. See, the thing about TI-84, if you don't have your windows set and you're scaling, okay, then it's not going to give you precise points like integers when you trace. And so, or you can go into table set. You can go into tables and look at the tables. Sometimes I like doing that. So if you look at x is greater than or equal to 4, so if you go to 4 right here, you see that the numbers, the y values, and this is this column is going to be, where's my, this column y1 was the absolute value function, that one was the horizontal line, thus 5, 5, 5, 5, 5, 5. So if you look at where x was 4 equals 5, then we need to find numbers that are greater than 5. So it equals 5, and it gets bigger than 5. So it's going to be x is greater than or equal to 4. And then we're trying to look for negative. If we look at negative right here, -1, okay, right here it tells us that it starts at 5 and it starts getting bigger. The y value gets bigger when x is less than or equal to -1. Okay, so I know that that's right. Okay, once again, less than, it's going to become a compound fraction. Greater than. Just putting equal signs wherever I feel like it. Okay, and then subtract 3, -8, -2x, and 2. Divide by -2. We are going to do a U-turn on all of our inequalities. Okay. So now another way for you to check is look at these boundaries right here. Okay, we're 4 and -1, and actually put those in, and then see if they work, and then try numbers that are in between that, like 0, and see if that works. Okay, or you could just graph it. But this video is already 58 minutes long, so I'm just going to go and say that is the correct answer. Let's see. Okay. Next one. E. Once again, I'm going to square both sides. Okay. That gets rid of the absolute value, so that's 4x squared. 2 times 3 is 6, times 2 is plus 12, plus 9, x squared. 3 times 1 is 3, times 2, plus 9. Let's go ahead and it's negative x squared minus 6x minus 9 and 0. So that is 3x squared plus 6x is greater than 0. Factor out an x. So we have, let's factor out a 3x. So we have x plus 2 greater than 0. So this is going to tell me, once again, using that greater than. Okay, and you can test the limit. You can test it on a linear, and you can test the 0 and -2 if you wanted to. But then I know that it's greater than, so it's going to be these right here. Okay, so that's going to be x is greater than 0 or x is less than -2. Okay, and both of them work. They should. Okay, usually when you have two absolute values, you'll have two intersections, unless they're the same absolute value functions, or they meet right at the vertex, which I don't think these two. You can tell by the equations that that's not going to happen. F. Okay, so I'm going to square both sides. And you don't have to. Once again, you could say it could be since I'm going to rewrite this. I always like to have the absolute value function less than x plus 6. So we know that 3x plus 2 has to be less than x plus 6, and 3x plus 2 has to be greater than negative x plus 6. Like that. Okay. Or you can square it. I just solved this. And then we have 2x. 4. X is less than 2. And this is going to be and because it's less than. It's going to be all of the numbers. Open circle, place that are in between. 3x plus 2, negative x minus 6. So 4x greater than negative 8. X is greater than negative 2. Okay, I could rewrite this in a compound inequality like that. And I think they both check out. Should I check it? Yeah, I think so. Okay, we have y equals x plus 6, x plus 6, and then the absolute value, 3x plus 2, graph the 2. Okay, you can see that they have 2 intersections right here, and it's saying that it's the area where the linear function, where's my detachable? It's the area where the linear function is going to be a greater than the area where it's greater than the absolute value function. So let me go ahead and take a picture of this here so I can kind of explain it a little bit better. There's Leo. Okay. Kind of like that. So I wrote here that the absolute value has to be, the output of the absolute value has to be less than the output of the linear function. So you can see that this is probably negative 2, and right here is probably 2. So those are the 2 intersections. Here's the absolute value. The y values of the absolute value here are lower than of this linear function right here. And so it's all of this area right here. All of that area right there. Okay? I hope that helps. Okay, good job. And then I realized I forgot to do D. Now this is going to be very interesting, the numbering of this. Or the chapters or whatever I put on this. Okay, so once again, we have the absolute value. 1 minus 3x is greater than or equal to 5, or 1 minus 3x is less than or equal to negative 5. So we have a negative 1, negative 1, negative 3x is greater than or equal to 4. And x is less than or equal to negative 4 over 3. And here we have a negative 1, negative 3x less than or equal to negative 6. X is greater than or equal to 2. and this is an or, and it should work out. I'll trust myself.